if I ask you to find the range of this function, f of x is equal to x square, which can take the input values in between -2 and 3, how will you do this? If your thought process is that I'll substitute the end values of the inputs to find the range, and something like this will be your answer, that is putting -2 inside the function, you will get output of 4, and putting 3 into the function, the output will be 9. And then if you will say that 4 to 9 becomes my answer, then this is absolutely wrong method and does not work for a lot of functions out there. It may work in some cases, but this is not the optimal way of finding the range. It basically states that the concept of range is not clear to you. And if that is the case, this video is definitely for you. So welcome everyone. And in this video, I'll make sure by the end of this, you will have a proper understanding of the word domain and range. And of course, there are multiple different kind of functions that exist in your AS level. Let's say straight line functions are there, and the quadratic functions are there, then cubic is there. Then we have something called as trigonometric function. There are a lot of trigonometric functions out there, sine, cos, tan. And then there are reciprocal functions. There are square root functions. So yes, there are multiple different kind of functions out there. For each type of function, I'll create a separate video in this playlist where you can understand and practice that how per function you will be able to find either of the domain or the range. So yes, in this video, I'll make sure at least the concept of domain and range is clear, and in the upcoming videos of this playlist, you will have a proper understanding that per function how you're supposed to find them. So let's get started. First of all, let's talk about domain. So what do we mean by the term domain? Let me explain that with an example and then I'll go over this definition. So if you're having a function f of x is equals to 1 over x, what does this mean? This means that you can pass whatever input to a function and a function will take that input value and provide some kind of an output. That is a standard way of how a function behaves. So if I tell you what is that one value of x in this case, where a function cannot provide an output, let's set x is equal to 3. If I pass 3 as an input, output will be of course 1 over 3, right? If I pass x as 3, the output will be 1 over x. So because x is 3, it will be 1 over 3. If I pass, let's say, f of minus 3, the output will be 1 over minus 3. So for these values of x, we are getting an output. My question to you is, what is that 1x value at which this function will fail to produce an output? So of course, if you are somewhat aware about the idea of 1 by 0, you will know that this kind of a number is pretty large, that we can't define it. Or in other words, we can say that it is infinity. So we are not having a particular output over here when anytime the denominator becomes 0. So in this case, I can say that f of 0 does not exist in this function. So domain states that it can take all the input values. Basically, domain is the input values only. But what input values? Only those input values at which you get a particular output. If you are going to take an input to a function which cannot provide an output, that values are not part of the domain. You should exclude all those values. So in this case, 0 is the only one value at which I can say that the function fails to produce an output. So how will I define a domain? I will say that the domain for this function, which are nothing but the input values a function can take, such that the function never fails to produce an output. I will say that in this case, my x is either greater than 0 or x is less than 0. Or I could have also said that x belongs to all real numbers. This is the symbol for the belongs to. This is the symbol for the real numbers. And then you can say that except x is equal to 0. There are two ways to write the same thing. Over here also we are saying that x can take all the values except 0. Over here also we are saying that x can take all real numbers except 0. So yes, one and the same thing. You can choose how you want to write. Now, how do we define a function? Whenever we are defining a function, let's say 1 by x, we don't just write 1 by x. Along with 1 by x, we make sure we write its domain as well. So with, let's say, a semicolon, you can say that x is less than 0 or x is greater than 0. You can choose either of the way to write the domain. Both of them are accepted in your AS level. And why is it always necessary to write a domain next to a function? Because we are stating that this function will produce output only for these values of x. If you put any other value other than the domain values, it means that the function will not exist on those values. And that is why this becomes very important part of the functions. So next time, whenever you are defining a function, always think about what domain should I write next to it. And how do you think about this? Think about all those values of inputs on which a function cannot produce some kind of output. Exclude those values and include everything else as a part of your domain. You can write it with a semicolon next to your function like this. So yes, now let's take a look on the definition of the domain. So domain are all the input values a function is allowed to take. And function is not allowed to take those values where it breaks, or in other words, where it fails to produce an output. So I hope that this definition is now clear to you. Now why have I written x-axis over here? Because whenever you will be plotting any kind of a function, straight line, cubic, whatever kind of function, the x-axis basically indicates that you are plotting your domain values. Inputs are plotted on the x-axis. And that is the reason I have written x-axis over here. Now let me show you some other example over here to understand the domain in a proper way. So here are three other examples that we are going to go through on top of 1 over x that we already covered so that you can understand the domain in a better way. Please note that for every function that I'm writing, it is incomplete without its domain that I've written next to it. Okay, that is why I have written a note over here that a function cannot be defined without its domain. And next time, as I mentioned, whenever you write a function, whatever it is, you will have to write a domain next to it 100%. Okay, if you are someone who is watching my video, it is your duty that you follow this particular idea. Now there are two majority of the cases in the AS level where you will have to think about where the function breaks or where a function cannot provide some kind of an output. Because if you remember, at the starting of this video, I talked about there are different kind of functions like a straight line, quadratic, cubic, then trigonometric, then let's say a reciprocal, square root, right? Over here, if you have ever dealt with this kind of functions even once in your life, you must have realized that your straight line never breaks. For all the inputs, it will be able to provide an output. Similarly, for the square root, the square and the cubic function. In trigonometry, in sine and cos, for all the inputs, you will always get an output. But for the tan, it is not the case. But yes, tan is slightly difficult to understand. So I'll cover the 10x topic in a separate video under this playlist where I'll talk about how do you find the range of a trigonometric function. Okay. But apart from this 10x graph, there is a reciprocal graph which exists like, there is something in the denominator where x is present. And there is a square root graph which cannot take a negative value as an input. So these are the two majority of the functions apart from the 10x function of course, where a function can break. Apart from this, there is no possibility. And that is why under the example, I have written two cases specifically for your AS level where you need to understand where a function will fail to produce an output. The first case is the reciprocal functions. When the denominator becomes 0, you exclude those values from the domain. Everything else becomes part of your domain. And the second thing is in the square root function. Whenever an x value or an input value forms a negative number inside the square root, you are going to exclude that x value. Everything else is a part of your domain. So why is this case? Because of course, as you can see from the reciprocal function, for x value, there is no output. And that is why we say that the function is breaking over there when x is equal to 0. Similarly, for the square root graphs, you have always seen that the square root graph exists only for the positive input values of the square root. There is no graph on the left hand side. And that is why this kind of restrictions are important to keep in mind. So now keeping this kind of ideas, let's look into this three different examples to understand how to find its domain. Starting with this function. Because it's a reciprocal function, we need to make sure that the denominator does not equal to 0. So if I say that 3 minus 2x is equal to 0, I'll get x is equals to, if I make x the subject of formula, it will become 3 by 2. So when x will be equal to 3 by 2, this function will become undefined, or basically there is no output for x is equal to 3 by 2. So I will say that this function is valid for all the real values of x except 3 by 2. So that becomes its domain. Similarly, the next question or the next two questions are from the square root. The first one is simply square root of x. So of course, square root of 0 and everything above that. For that value, the function will be able to produce an output. But the moment I am having some kind of a negative value, whatever negative value, my function is going to break. It will not produce any output. Therefore, this function is only valid for x that is either equal to 0 or greater than 0. So that becomes the domain for this function square root of x. Now the last example, f of x is equal to square root of x minus 3. Now I just need to make sure that x minus 3 is always greater than equal to 0, or else this function will fail. So if I'm having x minus 3 that is always greater than equal to 0, I can make x the subject of formula that will become x is greater than equal to 3. So of course, when x will be equal to 3, the square root will become 0. Anything that is greater than 3, inside the square root, a positive number will be formed, and therefore every time you will get an output. But then if you are putting any number that is less than 3, let's say 2.5. So 2.5 minus 3 will produce a negative number. So anything less than 3 cannot be passed as an input to this function. So yes, that is why we are saying that this function is valid for the domain x greater than equal to 3. So yes, I hope that along with these examples, you have understood the concept of domain. Please note that once again I'm repeating, for the 10x curve also, I have not really explained how to define its domain, but I'll talk about this in a separate video inside this playlist only. But now it's time to move on to the next concept, that is range. So far, we have looked at if we are defining a function, let's say whatever it is, let's talk about x squared this time, a square function or a quadratic function. We know that how do you control the input values of a function with the help of domain. But now, what about this range? So input values is something for a function that we have talked about, but we are not yet talking about the output values a function can produce based on every single input values of the domain. Let's say if I'm talking about x squared, of course this is valid for all the real numbers. There is no value of x on which a function can break, and that is why this becomes the domain of this function. So whatever x value you can put inside this function, you will always get an output. And all these output values a function is able to produce, those output values are called as range. So the definition of the function states that all the output values that a function is able to produce based on each input values from the domain, that is range. And as I'd mentioned, the input values are nothing but the domain that you plot on your x-axis. The output values a function can give is the range that you can plot on your y-axis. And that is why I have written y-axis for the output over here. Now, at the starting of the video, I had given you an example that f of x is defined as x square in between -2 and some number was there, let's say 3. Okay, wait. You might be wondering that what is exactly happening. Over here, I'm saying that x belongs to all real numbers. Over here, I'm saying that the inputs are exactly in between -2 and 3. So what is the domain? Well, for the same expression, you can have multiple domains. This becomes the overall domain, but if you want, you can restrict the domain. You can have control over that input values for every function. Okay, so I'll talk about this at the end of this video. But for now, the function that I had given you at the starting of the video, in which the domain was in between -2 and 3, you were saying that I'll plug in the values to find the output, and those outputs between that the range will be defined. That is the most illogical way of thinking about the range. Okay, so let me explain that how exactly you can find the range for any given function, or what is the optimal way to find the range of any given function. So the best way to find the range of any given function is to have a quick rough sketch of it in front of you, and then because the function sketch is in front of you, you can see that what is the minimum value of the output and the maximum value of the output. Okay, as I mentioned that in the graph, let's say if I draw the graph of x square only. In this graph, whenever I'm drawing an arrow means that can go up forever. As the x increases, my y value also increases. That is what I'm showing over here. Similarly over here, as my x becomes more and more negative, the output becomes larger and larger. That is what I'm trying to show with the arrows. Okay, so that is how the x square graph looks like. Now, if you are having a function right in front of you, you can clearly see that this is the minimum output a function is able to produce, and output is nothing but the range on that we plot on the y-axis. This the minimum value of the y is 0, and the maximum it can go up to is infinity. It will never stop. For all the x values, you can see right in front of your eyes that the minimum value this function can produce is 0, and the maximum it can go for any x, the maximum it can go is still infinity. So what becomes the range over here? Range of this function of x square where the domain is all real numbers. Okay, I'm yet not talking about this example. I'm talking if the domain belongs to all real numbers. For that case, my outputs can be in between 0 to infinity. Or in short, anything that is greater than or equal to 0, that is part of my range. So I can say for this function, my output values are greater than 0 or equal to 0, because of course when x will be equal to 0, the output will be 0. So 0 is also part of the range, that is the output. So that is how I define the range of the function if this is my domain. But now let's say this is not my domain. In that case, what we are supposed to do? Let's say the domain now is the second case, that is -2 to 3. So let me quickly plot on the diagram where it's going to be. My -2 is over here, and let's say 3 is somewhere over here. So at -2, the output of -2 square will be of course 4. So let's say this value on the y-axis is 4. And if I put 3 as an input, the output will be 9. So let's say 9 is somewhere over here. Of course, the graph is a rough graph. So the scale is not important over here, because you're just trying to see that what is the minimum and what is the maximum a graph can take as an output, or it can produce as an output. So in this case, because my domain just take the values in between -2 and 3. So all the outputs in between that is the only thing I'll consider as a part of the output. I'll not consider this part as an output. I'll not consider this part as an output because my graph is restricted between the input values -2 to 3, and the output it produces are over here. I'll mark it in a red color. These are the outputs that it produces. Now, what is the minimum value this function can produce? Again, it is 0. The minimum it can go is 0, and the maximum, as you can clearly see, is this value 9. This is the maximum value. So I can say that this function x square, if it is having the domain of -2 to 3, the respective outputs it can produce will lie in between 0 to 9. So 0 is the minimum value and 9 is the maximum value. So a function can produce anything between that. Now, is 0 and 9 are part of the outputs, or just below 9 or maybe just greater than 0 are part of the range? So clearly we know that the output of 0 is produced when the input was 0. And because 0 was part of your domain, it means output 0 is also part of your range. Similarly, as 3 is also part of your domain where you got 9, so we can say that 9 is also included as a part of the range. So this becomes the final answer for what is the range of the function x square in between -2 and 3. The minimum value was 0, the maximum value was 9. So your output is going to be in between 0 to 9, and therefore we say this is the range. Previously you said that the answer is in between 4 to 9, which clearly does not make sense, because you are saying that okay, between this values only 4 and 9 you are having the outputs. If -2 and 3 was the domain, only the values between 4 to 9 is the part of the output. And what happens to all these values? You have excluded all the values in between 0 to 4 if this was your answer. And that is why it is very important that you draw the sketch or a very rough sketch to understand how do you find the range of any given function. And as I had mentioned, there are a lot of different kind of functions in your AS level. So for each function, you should be aware about how to draw a quick graph. And for that, I create multiple videos in this playlist. For each videos, you will be mastering how to create sketches very quickly per function. So yes, all of that is there in this playlist. So make sure you are watching each of these videos to become really good at range. Trust me, my students never fail at this kind of questions. And a true mathematician, the symbol of a true mathematician is that you are able to visualize the concept. And range is one of my favorite topics of the pure mathematics, because you will have to sketch the graph. It will make you visualize, okay, yeah, this is the graph. And from the graph, I can see that this is my minimum value, this is my maximum value. So range are the outputs in between these two values. That is the flavor of mathematics I love the most. So I hope that the idea behind the range is now clear. And the question that I had given you earlier, that what is the range in between -2 and 3 for the function x square, it is not in between 4 to 9, it is in between 0 to 9. So now, as a part of your notes, I'll be writing something over here. The first thing is the common mistake while you are finding the range. As I've already explained and proved, that simply plugging in the numbers to find the range does not work magically. It works only in certain cases where the turning points are not present. So in the functions like, let's say, a square function or a quadratic function, in a cubic function, right? In this kind of cases, or even let's say in the sine graph, in the cosine graph, this kind of things will fail. Where does this kind of thing work? Let's say if you're not having a turning point, one of the example is a straight line. This thing will work in this kind of scenarios. Or maybe, let's say if you are dealing with a quadratic graph, but in a quadratic graph, the turning point does not come into the picture. Let's say if you are just to the right side of your turning point, and this part of the graph is what you're looking into. So because there is no turning point over here, this is still going to work. Plug in the values and you get the answer. This is the minimum output. This is the maximum output. So your range lies in between these two values. But yes, this is exceptional. And in either of the cases, you can see that if you are having a graph in front of you, it becomes very easy to identify what is the range. And that is why the common mistake that you should be avoiding while finding the range is to simply plug in the values without understanding it. I hope that is clear to you now. Now, important notes. Whenever we are writing a function, it may look very same. You can see in both the cases, f of x and g of x, there are two different functions, but it looks just the same. As I'd also taken an example in the previous case, in one case I said that x belongs to all real numbers. In one case I said that x is in between -2 and 3. These were also two other functions. So two other functions and these two other functions, in total we have defined four functions which looks exactly same x square, but all of them are different to each other just because their domains are different. If a single value in the domain or the range is different from each other, they are considered to be a different function altogether. Okay, so I'll not include the x belonging to our example, but let's say every other example over here are having different values of x from each other. Even if there is one single value like that, we say that both of them are a different function. So clearly over here, these two are also a different function whose range, if you are trying to find, you will need to plot a graph very quickly. So x square looks like this. If I talk about the first part where the domain is greater than equal to 0, so of course this is where 0 lies. So everything to the right is going to be part of the output, because x is greater than equal to 0. In this case, what is the output a function can produce? Of course, this is the minimum value and the maximum value is going till infinity. So I can say that output lies in between 0 to infinity, or anything greater than 0 or equal to 0 is part of your output. And that is why this becomes your range for the function f of x. So f of x is the output itself. We are saying that it is going to be greater than equal to 0. Why did the equal to sign come into the picture? Because the 0 was output when x was 0, and because x equal to 0 was part of your domain, we are saying that 0, which is the output of that x is equal to 0, is also part of the range. Now talking about the second function, again it is x square, we can utilize the same graph, but the domain is to the left of -2, such that -2 is not included as a part of the domain. So -2 is over here. And if a value is not part of the domain, the output with respect to that is also not part of the range. You can draw some kind of a circle to say that whatever is the output, in this case it is 4, it is not part of the output. But yes, as the domain is all the values to the left of -2, the function is going to produce these outputs in purple that I have drawn over here. So what is the range over here? All the values that are greater than 4, I am not saying greater than equal to 4, I am saying greater than 4. All those values are part of the range of the function g of x. Okay, so because I'm saying all the values greater than 4 from the graph, right, maximum is infinity, minimum is 4. So the range will be everything above 4, such that 4 is not included. That is why I have not written equal to sign over here. Okay, once again, 4 is not included as a part of your range, as -2 gave you this 4, and because -2 is not part of the domain, 4 is not part of the range. So I hope that even in this example, you have understood how do you find the range for a function. And the important part that I was talking about over here was that a function may look same, but they are different even if one of the values in the domain are different from the other function. Okay, that is the main thing that I was trying to prove. So a function can have a restricted domain, that is what we have already seen, that for x square, x belonging to the real number was the true domain or the overall domain. But then you can have greater than equal to 0, less than -2, or any kind of a restricted domain you can create. Okay, in your examination, most of the times they'll give you domain in the question itself, so you don't have to worry about it. But yes, the important concept is a domain can be restricted. And the second important thing, two functions can look the same, but their domains make them different. Okay, I've also written a note over here that even though that x square is the same graph, but the pink graph is different than the green graph, we say that both of them are a different function, even though x square is a common expression to represent them. The x values do not match completely, but then there is one more thing, as I mentioned, that even if there is one x value that does not match, we can say that it is not part of the same function. In this case, that is exactly what I am explaining. In this case, it is x square, over here also x square. This is greater than equal to 0, this is greater than 0. As the function f of x includes x is equal to 0 as a part of the domain, but in this g of x, we don't include x is equal to 0 as a part of the domain. Both of them look exactly same. The only difference is the equal to sign over here. But still, they are different. Just because this function cannot take 0 as the domain, but this can. They are two different functions. Okay, and this is the graphical representation for the same. I have included a dot over here which is filled, and a circle over here which is basically not filled. So that is a excluded value from the domain, and this means that 0 is included. So yes, even though the graph looks very similar, but even one single value is different, we say that the function is different. So yes, that is the entire concept of domain and range. So a quick revision before we end this video. Domain is basically all the input values a function can accept as an input such that it does not break a function. Okay, and I've given you two cases where in AS level you will see that a function can break. Apart from the 10x, the 10x will be covered in a separate graph, I mean in a separate video. But yeah, over here when you're dealing with the reciprocal functions, in reciprocal functions, the denominator cannot be 0. So exclude all those values of x where a denominator can become 0. That is the first case. The second case was the square root functions. The square root cannot accept a negative value. So exclude all the values of x where under the square root it becomes less than equal to 0. Okay. And talking about the range are the output values a function can produce based on every single value of the domain. And those outputs are your range. What is the best way to find the range? It is to sketch a function and check the output values. And the example that I taken, there were multiple examples that I take, mostly with respect to x square, so that you understand it properly. And yeah, we had seen that once we plot a graph, all the things becomes clear that what is the minimum value, what is the maximum value, and between the minimum to maximum you can say that the range lies. Okay. And the common mistake that students make is simply to plug in the end values of the inputs to get the end values of the output, which we saw that it is incorrect. Okay. And the important notes about the function is that a function can have a restricted domain on top of its whole domain. Okay. Over here I've discussed about how do you find the whole domain, but from that whole domain, if you want, you can take different chunks of the x values and create another function. And that is what I'd explained over here. This is also x square, this is also x square. This one takes greater than equal to 0 values, this takes less than minus 2 values, so both of them are different. Okay. And for both of them we also saw how do you find the range for it. And one last thing, that even though everything looks same, but even one value in the domain is different than the second function, both the functions are said to be different from each other. So yes, that was the idea behind the domain and range. In the upcoming videos, I'll show you that per function. Okay, how do you sketch the graphs very quickly, and from that, how do you find the range? So stay tuned for that. And once the videos will be uploaded, I'll just attach the link as a part of the description of this video, or maybe the I button may be popping up right now in front of your screen. If you understood this video and the concept of the domain and range, please leave a like on this video and share it with your friends if this is the whole new thing that you are learning other than what your teachers might have explained already at your school. Thank you so much, guys.